Saving the Appearances, A Study in Idolatry by Owen Barfield, 2nd edition. 8. Technology and Truth. We have just distinguished between the actual doctrines of modern science and the collective representations to which the growth of science has contributed. Thus, on the one hand, attention may be directed to the history of alpha thinking itself, what is ordinarily called the history of thought or the history of ideas. On the other hand, it may be turned to the effects of an alpha thinking which has continued long and widely enough to pass over into figuration, and be, as it were, smitten into the representations themselves, that is, a part of the history of consciousness, and of the collective representations which are its correlative. Now, although my subject is not the doctrines of science, but rather the collective representations, which have been so deeply affected by the doctrines of science, it may be well to pause here for a moment and consider the relation of scientific theories to truth and knowledge. What is the view taken by scientists themselves of that relation? The answer is not very clear, and it is a good deal less clear today than it was a generation ago. The limited scope of all scientific inquiry is today often emphasized rather strongly by those engaged in it, so much so that when we have heard them on the subject, we are sometimes left with the feeling that we ought to look on all scientific theories as mere hypotheses, in the sense of the Platonic and medieval astronomers, and that it is wrong to take any of them with the literalness that embroiled Galileo with the Church. They are, at best, we are assured, the mathematical formulae which, up to the time of writing, have been found the simplest and most convenient for saving the appearances. In physics in particular, there is a marked tendency to treat almost as an enfant terrible anyone who takes the models literally enough to refer to them in any context outside that of physical inquiry itself. It would seem to follow from this that, as Plato and the astronomers believed, the scientific hypotheses have no direct relation to the real nature of things. On the other hand, I find something equivocal in the public utterances of the spokesmen of science. For the same ones who have just been stressing this unpretentious view of scientific theory will frequently let drop some such phrase as, "Someday we may know," or even, "we now know," when speaking not of some particular hypothesis, but of quite general conclusions about the nature of the universe, earth, or man. Moreover, if the occasion is a formal one, we often get some reference to the history of science in terms of advancing the frontiers of knowledge, and so forth. All this indicates a very different conception of science and strongly suggests to the audience that modern science, so far from being disentitled to claim the status of knowledge, is the only reliable knowledge available to us. At the least, it suggests that the findings of any particular science are not merely tools for the application and further pursuit of that science, but have some sort of absolute validity. Perhaps the confusion is at present unavoidable, but let us at least be clear that it is a confusion between two quite incompatible views. Let us see, for instance, what consequences flow from adopting the first view, namely, that scientific theories are simply hypotheses to save the appearances. This can best be done with the help of a grotesquely oversimplified analogy. But first, let me make the bearing of the analogy clear. It will contrast two different sorts of knowledge, both of which, in the analogy, depend on alpha thinking, but it will illustrate the difference between a knowledge which does depend on alpha thinking and a different kind of knowledge altogether which does not. Plato and Aristotle and others, as we have seen, taught that there was such a knowledge and that it was accessible only to participation. But it is not necessary to believe this in order to understand the analogy. Take a clever boy who knows nothing about the principle of internal combustion or the inside of an engine, and leave him inside a motor car, first telling him to move the various knobs, switches, and levers about and see what happens. If no disaster supervenes, he will end by finding himself able to drive the car. It will then be true to say that he knows how to drive the car, but untrue to say that he knows the car. As to that, the most we could say would be that he has an operative knowledge of it, because for operation all that is required is good empirical acquaintance with the dashboard and the pedals. Whatever we say, it is obvious that what he has is very different from the knowledge of someone else who has studied mechanics, internal combustion, and the construction of motor cars, though he has perhaps never driven a car in his life and is perhaps too nervous to try. Now, whether or no there is another kind of knowledge of nature which corresponds to engine knowledge in the analogy, it seems that if the first view of nature of scientific theory is accepted, the kind of knowledge aimed at by science must be, in effect, what I will call dashboard knowledge. Francis Bacon, whose startlingly original mind was so influential in bringing about the scientific revolution, was very frank about this. Not only did he maintain that knowledge was to be valued for the power it gives man over nature, but he practically made success in this aim a part of his definition of knowledge. The key words he uses to distinguish the knowledge he exalts from the knowledge pursued by the schoolmen are fruit and operation. In other words, not only science, but knowledge itself, that is, the only knowledge that is not mere trifling, is for him technology. Knowledge, for which Bacon, when he wrote in Latin, of course he used the word scientia, is that which enables us to make nature do our bidding. I think it must be acknowledged that the idea which stands behind the particular kind of knowledge which we have come to call science is dashboard knowledge. I mean only that is its mode of knowing. I do not, of course, mean that the motive by which the great scientists have been inspired has been the desire for power. The analogy is admittedly a crude one, for while the dashboard of even the most expensive and up-to-date car is a comparatively simple affair, nature's dashboard, that is, her exterior accessible to the senses and the reason, is of such a marvelous and intricate complexity that many a man has counted his life well spent in mastering a tiny corner of it. If, however, it is acknowledged, what follows? If science is merely technology, if the theories of physics in particular are mere hypotheses to save the appearances with no necessary relation to ultimate truth, then, well, in the first place, one hopes that the car will not break down. But, in the second place, it might be argued that they should be consistently treated as such. It might be said that the theories of physics should be reserved for the purposes of physics and left out of sight altogether when we are thinking about anything else, about the nature of perception, for instance. This would remove the foundation from under the first part of this book, but it would also have so many other and such startling consequences that I am not seriously alarmed. For, in the first place, we could not limit the new and more hypothetical way of thinking to nuclear or recent physics. The laws of gravity, for example, and of inertia must go the same way as the electrons, as far as any ultimate validity is concerned. Secondly, you cannot really isolate one science from others in this way, nor is it the practice to do so. One has only to think of the effects of physical theory, treated as fact, on the sciences of medicine and astronomy, as exemplified in radiotherapy and astrophysics. Thirdly, and most important of all for my purposes, the hypotheses do in fact get into the collective representations. Many of them are, and others soon may be, implicit in the very nature which surrounds us, and therefore in the world in which I have to write. And lastly, the withdrawal from participation, which alpha thinking has brought about, has its advantages. The vagaries of confusion and savagery in the tribes in which anthropology finds participation most conspicuously surviving today, though they may well not be very reliable guides to its ancient quality among other peoples who have long since abandoned it, do nevertheless remind us of the sins of commission in thought, feeling, and action of which the original participation is capable. Whatever sins of omission alpha thinking may be guilty of, we owe to it, up to now, our independence, much of our security, our psychological integrity, and perhaps our very existence as individuals. When Prospero renounced his last enchantments and set sail for civilization, Ariel, it is true, remained with Caliban, but so did Setebos. Apart from all this, there is one conclusive reason why, in spite of the technological slant of natural science, our beta thinking is bound to begin with the assumption that alpha thinking has a valid relation to truth. With collective representations like ours, what else can we do? Where else can we start from? If the physical theory of an unrepresented base has some such validity, so much the better. If not, even if it amounts to positive error, the way out may still lie not through and not back. The best way of escape from deep-rooted error has often proved to be to pursue it to its logical conclusions. That is, to go on taking it seriously and see what follows. Only we must be consistent. We must take it really seriously. We must give up doublethink, for inconsistent and slovenly thought can abide indefinitely in error without any feeling of discomfort. 9. An evolution of idols. It is the common opinion that, whereas we see nature pretty much as she really is, primitive man sees, and archaic or early man saw her all awry through the veil of a complicated system of fancies and beliefs. If, however, the general conclusions of Chapter 4 are accepted, it is clear that whether or no archaic man saw nature awry, what he saw was not primarily determined by beliefs. On the other hand, it was suggested in Chapter 7 that what we see is so determined. If I am right, therefore, there is indeed a contrast between primitive and modern consciousness, and that contrast is connected with beliefs, but in exactly the opposite way to what is generally supposed. Precisely what beliefs about phenomena have been widely and confidently and long enough held to become actually part of a representation is, as I have said, a matter on which opinions may well differ in any particular case. But whether they are part of our collective representations or not, it is a fact that there are certain beliefs not only about the structure, but also about the history of the phenomena surrounding them, which are widely, indeed almost universally, shared by civilized men in this second half of the 20th century. There are also beliefs, only a little less confidently and a little less universally held, about the history of consciousness. As both these sets of beliefs run sharply counter to a good deal of what I have said and intend to say on the same subject, it will be well to give some indication of how and why these, in my view, mistaken beliefs arose. But first of all, one more brief digression on the subject of science. Most of what I have said about it has connoted the experimental and practical category. Whether the theories of physics and astronomy, for instance, are truths or approximate truths, or whether they are mere hypotheses to save the appearances, the impressive thing about them is that they work. We predict the results of an experiment, we make the experiment, with all adequate safeguards, and the prediction is verified. In the case of astronomy, although we cannot experiment, we can still predict, and in doing so, test the efficiency of our hypotheses. They predict many years ahead eclipses of the sun and moon. They specify the day, the hour, and the extent, and their reckoning is correct. The events follow their predictions. They have discovered and recorded rules by which it can be foretold in what year, in what month of the year, on what day of the month, at what hour of the day, in what part of their light the sun and moon are to be eclipsed, and what is foretold occurs. These words are, of course, not less, but much more true of the Copernican and Newtonian hypotheses of today than they were of the Ptolemaic and contemporary hypotheses to which St. Augustine was referring when he wrote them in his Confessions at about the end of the 4th century A.D. By their fruits, as Bacon would have said, we know them. But there are today, alongside the practical and experimental sciences, a number of others which are, it seems to me, in a much less happy position. I suppose a large part of astrophysics, for example, to be unverifiable by any prediction or experiment, but I am concerned here more with sciences such as paleontology and a good part of geology and zoology, whose subject matter is the past, which naturally cannot be predicted and is not either susceptible of experiment. Here we cannot say with Bacon, never mind what those tedious old fools and the schoolmen meant by knowledge, does it deliver the goods? For the only goods to be delivered are knowledge. There is no operation, no fruit, and no empirical test of accuracy. If their hypotheses are not also the actual truth, they are nothing. It seems to me that the only thing which such purely theoretical sciences really have in common with those at the technological end of the scale is the healthy discipline, the open-minded attitude to fact which is, or should be, common to all whose object is knowledge, and which has itself become so much better understood and acknowledged as a result of the systematic pursuit of empirical science. But it also seems to me that they have in fact borrowed very much more than this. They have, for instance, accepted many of the hypotheses of sister sciences as established fact, according to them the same status in the construction of their theories as to their own first-hand observation. In this connection, I have already pointed out in Chapter 5 that they have accepted some of these hypotheses, while choosing to ignore others. They have, moreover, borrowed half the vocabulary of hypotheses and empirical verification and are deeply colored by the technological mode of knowledge which that implies, though it is really quite inappropriate to them. It is almost as if they expected dashboard knowledge to tell us how the engine was made. I believe this to be one of the reasons, though not the most important one, for the hypothetical picture of the evolution of the earth and man, which began at about the end of the 18th century to fasten itself on men's minds, and which is today regarded by ordinary men, as are all but the most recent and avowedly tentative of scientific hypotheses, as palpable fact, which indeed, it may be argued, has become part of their collective representations. At the beginning of the 18th century, the variety of natural species was normally attributed by the botany and zoology of the day to supernatural and instantaneous creation. The 18th and 19th centuries witnessed the almost total disappearance of this tradition, reflected as it was in the elaborately classifying botany of Linnaeus, in favor of a gradual evolution. In the record of the rocks and the dovetailed panorama of organic nature, history and science together gradually divined the vestiges of a different, a natural kind of creation, and one that was the reverse of instantaneous. Nature herself came to be seen as a process in time, and the individual phenomena at any point, instead of being fixed and parallel shapes repeated and repeated since creation's day, were cross-sections of their own development and metamorphosis. They could be truly grasped only by looking before and after. A consideration of the identical effect of this on our whole conception of the significance of history, and indeed of time itself, must be deferred to a later chapter. Suffice it here to say that the upheaval was all the greater, indeed it amounted in the end to something like an explosion, because it came at a time when the mind of Europe was perhaps more disinclined to look forward than at any time in its history. The backward-looking mood of the revival of learning had not yet died away, and most men were much less concerned with the shape of things to come than with the greatness and wisdom of the ancient Greeks and Romans, and the virtues of the noble savage, corrupted, it was held, by the advance of civilization. In this chapter, we are concerned with the form which the hypothesis ultimately took, and its effect on the collective representations. This was naturally determined to a large extent by the existing representations to which it was applied. What were the phenomena of nature at the time when the new doctrine began to take effect, and particularly at the Darwinian moment in the middle of the 19th century? They were objects. They were unparticipated to a degree which has never been surpassed before or since. The habit begun by scientific revolution of regarding the mechanical model constructed by alpha thinking as the actual and exclusive structure of the universe had sunk right into them. Hardy's rustics may indeed remind us that change did not proceed everywhere at the same rate, even in the English-speaking world, but for townsmen at least, in a world which was already rapidly and is now more rapidly still becoming totally urbanized, the last flicker of medieval participation had died away. Matter and force were enough. There was as yet no thought of an unrepresented base, for if the particles kept growing smaller and smaller, there would always be bigger and better glasses to see them through. The collapse of the mechanical model was not yet in sight, nor had any of those other factors which have since contributed to the passing of the dead center of literalness, idealist philosophies, genetic psychology, psychoanalysis, as yet begun to take effect. Consequently, there was as yet no dawning apprehension that the phenomena of the familiar world may be representations in the final sense of being the mental construct of the observer. Literalness reigned supreme. What, then, had alpha thinking achieved at precisely this point in the history of the West? It had temporarily set up the appearances of the familiar world, which the same thinking pursued a little further, pursued to the point which I have called beta, discovers to be so inextricably involved with man himself, as things wholly independent of man. It had clothed them with the independence and extrinsicality of the unrepresented itself. But a representation, which is collectively mistaken for an ultimate, ought not to be called a representation. It is an idol. Thus, the phenomena themselves are idols when they are imagined as enjoying that independence of human perception which can in fact only pertain to the unrepresented. If that is, for the most part, what our collective representations are today, it is even more certainly what they were in the second half of the 19th century. And it was to these collective representations that the evolutionists had to apply their alpha thinking, just as it was to the quite different representations of their own contemporaries that Plato and Aristotle had to apply theirs. It is to be wondered at that the evolution which the former have depicted is not a real evolution of phenomena at all, but, as was pointed out in Chapter 5, a factious extrapolation, an evolution of idols of the study. I am speaking, of course, of the form which the theory finally took, not of the concept of evolution itself. That is factual enough. The record of the rocks is a script containing stored memories of Earth's past. It is only a question of how the script is to be read. A touch of that participation which still linked the Greeks and even the medieval observer with his phenomena might well have led to a very different interpretation, as it did in the case of Goethe, who had that touch. But for the generality of men, participation was dead. The only link with the phenomena was through the senses, and they could no longer conceive of any manner in which either growth itself or the metamorphosis of individual and special growth could be determined from within. The appearances were idols. They had no within. Therefore, the evolution which had produced them could only be conceived mechanomorphically as a series of impacts of idols on other idols. If the impulse to construe as process the record of the rocks and the vestiges of creation apparent in the natural order had come either a little earlier, before participation had faded, or a little later, when the iconoclasm implicit in physical analysis and the beta thinking to which it can give rise had really begun to work, man might have read there the story of the coming into being pari passu of his world and his own consciousness. As it was, all that paleontology could take over from the experimental sciences such as astronomy and physics was the idols which these latter had so far succeeded in creating. Working with these, it attempted moreover to adopt the orthodox geometrizing tradition of those sciences with a slavishness that led, in one instance at least, to results whose absurdity is only just beginning to dawn on us. There is no more striking example than the Darwinian theory of that borrowing from the experimental by the non-experimental sciences to which I referred at the beginning of this chapter. It was found that the appearances on earth so much lack the regularity of the appearances in the sky that no systematic hypothesis will fit them. But astronomy and physics had taught men that the business of science is to find hypotheses to save the appearances. By a hypothesis, then, these early appearances must be saved. And saved they were by the hypothesis of chance variation. Now the concept of chance is precisely what a hypothesis is devised to save us from. Chance, in fact, equals no hypothesis. Yet so hypnotic at this moment in history was the influence of the idols and of the special mode of thought which had begotten them, that only a few, and their voices soon died away, were troubled by the fact that the impressive vocabulary of technological investigation was actually being used to denote its breakdown. As though, because it is something we can do with ourselves in the water, drowning should be included as one of the different ways of swimming.